The following podcast is brought to you by Vite Ramen. Use offer code BrokenSilicon to get 10% off tasty, healthy, and easy-to-make ramen orders at the link below, or use the offer code BrokenSilicon to get 25% off Windows keys at another sponsor, cdkeyoffers.com. Links for both are in the description. Now on with the show. Welcome to Broken Silicon, a gaming hardware and I guess sometimes AI and machine learning podcast. I am your host, Tom, and today, as always, I'll let my guest introduce himself.
I'm Ryan.
So we met at the Carolina Game Summit, and I only had so much time. I had to choose between certain meetings and certain guests, and I saw your talk about, or at the very beginning, your talk about I think it's working with machine learning and AI generated voice using AI generated voice, right? And I've been wanting to get someone on. I had an AI researcher on before, more so someone, if I remember correctly, I've interviewed so many people, it's hard to remember sometimes, who did AI training, for specific, types of actions. And you did something very different. And I think it's actually good to have someone on who's kind of starting in the field as well, because there's a bridge. You just are getting into this. And so I feel like you'll be uniquely able to explain what people are working on literally right now in machine learning and AI workloads to people who, I'm going to be honest, I still think it's usually buzzwords. And I still think most people, understandably, don't even really know what people are talking about when they talk about machine learning. So let me ask you this. What would you say the field of AI research even is? Like, if someone's like, what's AI research? What would be your answer? And I know it's a pretty open-ended question.
Yeah, it's pretty broad. And you're right. A lot of times AI is used in a sort of buzzword type of context because there's just so many different things going on in the field, from voice recognition to image recognition, image segmentation, natural language processing. The list goes on and on. And so when somebody asks like, what is AI? I sort of give a general, definition of AI, where we're using programs and systems to model some sort of aspect of human intelligence, whether it's learning or path planning, search. We're using algorithms to try to model what human intelligence is doing in different contexts.
And right, the more I'm starting to look into this more and more now that I'm fully familiar with this stuff. Apple's, they're adding a neural. They've added for a while now, actually, a neural engine to some of their chips. I now know Intel's looking to add that. I'm sure AMD is looking to do the same thing because they compete with Intel. So this is starting to become a thing where it's not just in, I don't know, kits that are used in a classroom or at some billion-dollar computer at IBM or something. We're talking about stuff that's starting to do on-device, processing of what that they just didn't ever used to do. And so I feel like it's time to start understanding it. I talked to you before we started recording this. Am I wrong to say that most, and I put in big quotes, AI research is just a very, very, very specific thing, usually trying to model one thing a human can do? No one's really, really working on trying to make a replicant of a human brain, right?
That's a funny question. The vast majority of AI research is in a very narrow and well-defined range of tasks or a scope or problem, with like highly labeled and very specific type of data, doing a very specific type of an analysis for one specific task. And that's the majority of AI research. Now, there are people out there trying to create some sort of generalized AI. Even at Biomojo, we are working on creating an intelligent chatbot, basically, that you can speak to and it'll speak back to you. But it is still very far from what you might consider a general AI. And anybody who's trying to do it now is is there's a long way to go.
How close would you say you're getting to people being able to tell that it's AI instead of a real person, right? Like, because I remember 10 years, was it 10 years ago? Maybe 8 years ago when I was in college, there was this thing that came out where they were trying to have a chat box that talked to you and it felt like it was a real person. I remember so many people in online forums being like, oh, I couldn't tell it wasn't a real person. And I was like, let me see. And then within 20 seconds, I was like, this is an AI. Like it already was starting to repeat itself. I don't remember what it was. It was a big deal that year because it was like the first time anyone made a big deal of trying to do that. Like, how do you measure success? Like, what I'm kind of asking is it based on, oh, they figured it out after 5 minutes when they were talking to them? Or is it like, oh, we know they're going to know it's AI, but they don't complain as much?
That's also a good question. I can't put a number on the number of years it's going to take. It depends on a lot of different tasks in AI research, and how far we can get with each one. Obviously, as we get better computing power, we can have better models. As we get higher quality data and more of it, we can have better models. But um, there's a lot to create a general AI. Like, at least if you're doing it today, there's a bunch of small tasks that you have to do, like natural language processing, speech recognition, and all these things. And any one of them can make a mistake, and you'd notice.
And then if two of them make a mistake, it's like exponentially bad.
Exactly. So it's difficult to tell exactly when we'll be able to not tell a difference. And there's this thing, I'm sure you're familiar with the Turing test, where it's like, okay, can this computer produce a response that can trick the Turing test into thinking it's an actual human? And it's really difficult to pinpoint human intelligence. And, that's a whole broad topic in of itself. But it's going to depend a lot on how far natural language processing research.
So how do you know when it's successful, right? You're trying to make a chat box. What makes it successful? How do you define it's successful or not?
How do we define if it's successful or not?
Because I'm going to be honest, I hate it right now. When I go, like if Best Buy has the chat box pop up, I'm just like spamming agent control cop. I type agent control C, and then I just keep spamming agent until it gives me a real person who will type to me. Because it is, and I mean this, a full waste of my time to even bother trying to use it. It slows me down. Well, I'd rather wait in line for a person.
Well, that's the thing. That's sort of dependent on the task that you're using it for. Because a lot of times just talking is slower than typing, or even talking to somebody. So like they have to fully understand the entire scope of what you're asking for it to even come close to being efficient for you to ask somebody or an AI a question. And so it really depends on this context understanding and the scope of how much it can understand of the context of a situation. And that's probably a couple of decades off before that's like able to maybe trick us for a few minutes.
Right. So that was the question then. So you think basically right now, well, how would I put it then? Well, you're kind of suggesting is there's no measure for success. They just know it won't be successful, but they're trying to not have as many workers. I mean, honestly, that's what you're saying. Is it like if it can save their real people 30 seconds, it's successful in their eyes?
Yeah. If it can reduce costs, they're going to do it. If it makes their business process, even a little bit better, they're going to do it. If some people will use it and get some benefit from it, they will still use it.
For me, I think it's so bad, though. I wonder if they're like, oh, look, this reduced the workloads on our workers by 30%. I would guess it's just because people aren't bothering to ask for help then. Honestly, it's like, yeah, your workers are less busy because people are leaving your website.
I could see that as well. I'm not familiar with the numbers and the reasons.
Oh, of course. But it sounds like what you're saying is if it takes time, because you're right, we don't think about it, but I ask you a question. I say one sentence. What your brain really just did is interpreted all those words, interpreted it as a sentence, translated it into exactly what I meant. In a microsecond, you understood every word, the grammar, and what I meant, pulled a file out of your brain and said, yeah, I think this. That's a lot of lag time if you have to go to the cloud to process it,
That right there, that's a whole nother aspect of it too. Because a lot of what people are doing in embedding in applications right now is on the cloud. And so being able to build things on the device, and reducing that latency and lag in response is another aspect of creating these AIs is can we make it faster? And because you're right, there's a lot of different tasks that need to be done all at once to fully respond to a question. And if it's on the cloud, it might not be fast enough to trick somebody into thinking it's not an AI.
Right. So what you're kind of what you're kind of just said is a reason why you see like Intel and Apple putting neural engines and stuff on device. See, there you go, because it's very hard to talk about neural engines. You even see Apple do a presentation and they're just like, they almost don't know how to tell you why it's important. But right there, I think we got an idea. It's like, well, how often are we using speech recognition? How often are we trying to plan the quickest route on Google Maps? If you could have some of the data done on device or some of the processing for like a Google Maps route done on device, that's half of it, because I don't think anyone thinks about how quickly our brain is doing about a million things at once when we talk to someone.
You're exactly right. Like the M1 chip with the neural engine, when I was doing my own research, there's just so many different applications just inside of the Apple phones and MacBooks that use neural networks and machine learning. There's like language translation, face recognition, app predictions, keyboard predictions, like when you're typing. There's speech to text, text to speech with Siri. They analyze your health information. There's a whole long list, and I could keep going. Not even talking about the cameras yet. They use these machine learning models all inside of the user experience, and that's exactly why they would use a neural network or neural engine. I mean,
right. Which I guess let's go straight then to this part of the script that we have here for things to discuss. Like, where do because I think you gave a few examples there, right? I think the quickest one I can come up with that I saw that's like, okay, I can directly understand why that's important is when you use Google Translate, you send it to the cloud, they process it, and then send it back. So first of all, you need a connection. And the connection, as far as I can tell, actually has to be pretty good. 2G is not going to cut it. And I think 3G, it even pretty much breaks down when I've tried. So you basically need 4G. You need to send the data. And if there's any glitch at any part of that, so shall we say processing supply chain, whether it breaks halfway through your recording, the mic, like there's so many things that can go wrong in sending that data to the cloud and coming back. That's something the neural engine can do. It can process what it's seeing on screen because you've already put together the program and how it does that, and you do it on device. Like, what other things do you think? Because now Intel's bringing one out, and it's not for a phone; it's for like laptops. What else do you think? How prevalent do you think it's going to become in applications? Like, how many, not just speech recognition or like Google Maps? How many things do you think could use this to save people time? Like even in video games or something. Can neural engines be used for smarter gaming AI than we could do without them? Like, do you think that is how we would scale it up eventually? Or
so with neural engines and gaming AI, like for like enemy characters, maybe if you're doing, especially on like an iPhone or an iPad, if you're playing a video game, like so mobile gaming, I could see that. I'm not familiar with the specific types of tasks and algorithms and networks.
They usually use the CPU, for the AI, and they just basically have an if-then, decision tree for every person on screen.
I can see neural networks being used in video games in a lot of different contexts. Even besides just the characters. And so it's there. I think it'll definitely be used to enhance a lot of the different images and maybe prediction models and things like that. Path planning, things like that. And it will make an impact on the quality of a game. If you can,
and it's not a trick question. It's not a trick question. I'm literally asking because I don't know. The way we program AI now, can a neural engine be used for that, or is it really used for different tasks? But you're saying, no, it could, and it could do it better than a CPU.
Very specific tasks.
Right, so most of it would still be done traditionally, but then there'd be some tasks you would probably throw over to the neural engine.
Exactly.
Okay.
That's exactly what happens on our phones already with like there's like a specific type of GPU in our phones. And that's exactly what would happen.
Right. And so this perfectly transitions into the next thing I want to bring up about this. We kind of got ahead of ourselves, but what are neural networks used for? Because when I talked to you before the show, and the more I talk about it now, like you're saying, oh no, we'll do, video game AI the same way we do now. It's just some of the tasks we'll throw over to the neural engine and it'll do it more efficiently than a traditional CPU with a if-then statement would. You're saying that's basically everything neural engines are for, is that most of the time you're still going to use a CPU or GPU. Most of the time that neural network isn't being used, but when it can be used, it can do it 100 times faster and use less energy. And that's why we're doing it, right?
Yeah, that's pretty much what it is. Neural networks are in a very narrow scope usually. They do very specific inputs and very specific outputs, and that's sort of at the heart of what they are. And so you can use them in very specific contexts. And that is in video games, and your iPhone, on your laptop, in all kinds of, maybe in, self-driving cars. There's very specific tasks that need to get done, but it can't represent the general application, if that makes sense.
Right. And I think we talked about this too, why they're being added, because if you go back to when Apple first added neural engines to their SoCs, people were like, why are they wasting, I don't know what it is, so don't quote me, people listening, but it was a decent amount of the die space. Why are they wasting 20% of the die space? Why can't I just have 12 cores on my phone or something instead of this stupid neural engine? And to be fair, for the first year, almost nothing used the neural engine, almost no apps did because it was new. But I think what me and you kind of discussed is, again, using the A15 as an example, from what I've seen in Cinebench benchmarks, it's kind of the equivalent of I don't know how you would put it, an underclocked Rocket Lake i5. In single core performance, it's pretty close to the latest Intel and AMD processors. It just is clocked lower, and then it only has 2 big cores and enough little cores for some multi-threaded tasks. Now, could they have made it, 16 cores on a phone, made it as strong? Maybe, but is there a point in that when you can add this neural engine that may not be used often and make some tests just way faster? In other words, the analogy I made to you was, we already have a GPU that's basically a fork and a CPU that's a spoon. Let's say a GPU is a fork, because I've seen a lot of people say GPUs can do anything neural engines can. And it's well, they can do most things, but they're going to use more energy. Every now and then, why would you make your fork bigger and bigger when you could just add a small spoon that, you have a big enough fork, dude. We don't need a bigger fork.
So that's pretty much exactly it. One way you can look at neural engines and what they do under the hood in a very, general sense. If you're writing a book, what a GPU will do is, take a stamp, line by line, prints one line at a time, not one character, but a whole line. And then the neural engine will just take a whole big page and stamp it all at once, and it'll flip the page, stamp the next one. And it ends up actually, compared to a GPU, I think it's 30 to 100 times faster. Might be getting my numbers a little bit wrong there, but that's the range. And it's because it's doing entire matrix multiplications all at once, as opposed to vector multiplications.
Right. And right. So in other words, they put a small one on first because nothing was using it right away, but they knew eventually it would be important. You have to start somewhere. And now the latest one, I think the CPU is barely better, the GPU is 30% better, and the neural engine's 50 to 100% better. And that's because now apps use it. And moving forward, I think the reason Intel's adding a neural engine with Meteor Lake is they go, do people need more than 16 cores? And then we're going to make the GPU stronger. Takes up very little die space for us to just add a small neural engine so your laptop can do everything an iPhone can do, right?
Yeah. It's also worth noting that I think, a lot of applications that we know of that people build didn't use the M1 chip yet because they just put it on there. But I think Apple themselves, in the applications that they build into the phone, use it at a ton, and they've been using it for the past 5 to 10 years. Some of the chips they have created are specificated for AI accelerating since iPhone 8, really. They've been doing this for a long time and slowly integrating it more and more into our experience. And I think that it was extremely useful for them to have a neural engine on their chip that maybe Intel wasn't providing.
Right. And you mean for their laptops as well?
Yeah, exactly.
Yeah, and that's funny to think about too. Would you say Intel and AMD? And again, I think, let's be fair, I think phones are going to use these types of operations more often because you're taking pictures with them and using them so quickly to look things up, or so often, should I say, to look things up. But Do you think Intel and AMD are kind of behind the ball and not adding one like a year ago or something? Like, uh, they're not as useful for laptops, obviously, but
Yeah.
still, at a certain point, it's like, why haven't you used 10% of the die for this?
So they're useful for laptops for like applications that people might be running, like maybe video games or word processing. I'm not really sure. They're definitely really useful for phones. But in terms of, do I think they're late? I personally was a little bit surprised that Intel isn't going to be releasing the first one for, maybe I can't remember the number, maybe 2022, 23.
23, it seems like, yeah, at the earliest. So
And
far, who knows? Maybe they'll put it in something else sooner, but that's what it seems like.
yeah, and Google, they've had the TPU since, I mean, they started researching it in 2013 or 12,
Hmm.
and they, like, once they realized that they were going to need the tensor processing unit, they went full steam ahead and had it within a year and a half, um, and that was like close to a decade ago.
Hmm.
So I don't want to say that Intel or AMD is late because they have their own business model that they're serving, and I don't fully understand that, but it did seem surprising to me.
Yeah, and I suppose it's just at least for AMD's perspective, it's a natural byproduct of the fact that their biggest margin and they send most of their silicon to like exascale servers where there's just hundreds of cores processing that types of data on a website. And it's like, and then they just bring a version of it to the consumer. They didn't need to add it yet. So yeah, I guess I would kind of say Intel is the most behind because so much of their money comes from laptop compared to AMD. It's almost, and then they lost the Apple contract. From what you're saying, probably a large degree because Apple was like, really, you're not adding one yet? Really?
That
Like it's going to take you
that's
this
what I
long?
thought.
Yeah.
That's sort of the impression that I've got. I don't want to make that kind of assumption, but it seems
We can
that
never
way.
be 100% sure, right?
Yeah,
But
it seems like the neural engine on that chip is extremely important for what Apple wants to do in their products, and it does seem like Intel's late to the ball, like they don't have it yet.
Want to get sent some nudes? I am proud to say that Vite Ramen is a sponsor of Moore's Law is Dead. The Vite Ramen Company is an American company that pays its workers fair wages and engineered a tasty, healthy, and cheap meal that you can cook in less than 5 minutes. So if you're busy, hungry, or just looking for a pre-made meal that isn't expensive, get some nudes sent to you. Click the link in the description and use the code BROKENSILICON to save 10% on your order. This helps me, this saves you money, and this supports a good company. Buy Vite Ramen today.
right. So I guess I want to get a couple other questions out of the way before we back up again to kind of just explain the differences between the more big picture stuff.
Mhm.
Since we're already on this line of thought, Jake Do 23 writes in and he says, "Greetings, esteemed guest." Apparently, you're esteemed.
Thank
I've
you.
been wondering. Yeah, I've been wondering if AI will ever truly be able to recognize speech and handwriting. My handwriting is pretty bad. A B actually looks like an L, if I'm being honest. But I'm wondering if you think AI will be able to figure me out. Also, speech. Right now, you need to tell your virtual assistant you will be speaking to it in the configuration menu beforehand. You might have a regional accent. Will a computer ever be able to both auto-detect which language you're speaking and what you're saying? And finally, ID. Is every person's voice and or handwriting different enough that you could train an AI to effectively ID all people? I personally think that would be very useful. Your computer would know who was talking to it and could answer either in a different voice, accent, or cadence, depending on who's in the family is using the phone at the time, for example. Anyway, sorry for this massive wall of text, and if it seems as poorly written as my L's or B's, but I'm leaving for a driving test in a few minutes, and I don't have time to do much in terms of rereading. Have a great day. So a lot in there, but it's kind of a general thought question,
Yeah,
right?
man, there's a lot in there. And something at the end he mentioned, will AI be able to tell who's talking to it? And I'd say it already can. Like the Apple iPhone already has a function in there where it'll only like Siri will only respond to your voice. And all you have to do is give it like a couple of voice recordings. I remember doing that in mine, and so that's all. Bio identification is used in a lot of different contexts, from your thumbprint to image or face recognition to there's voice recognition, obviously, as I was just talking about, and they can actually identify who's talking to it. who's talking based on the characteristics of the voice. And so that's already done. And your handwriting, yes, it AI can detect. You can train it with the data. I could feed it an A and label it as an L, and it will eventually learn that A is an L. Even though we know it's an A, the AI, depending on how you label it, it'll still learn exactly what you want it to learn. So if I forget, his B's look like an L, or something, or maybe the other way around. If you label it accurately, the application can learn. Basically, if you give it enough data, it will be able to learn.
Right. My question then, and I think what he's basically asking is, I'm aware it's supposed to be able to do this. And to be fair, I use an iPhone for work heavily, I don't know, 3 years ago. And I thought Siri was terrible at understanding me and terrible at identifying anything having to do with handwriting. Maybe it's gotten better. In fact, I would say I'm sure it has since then. But when will it get to a point where it doesn't take months of you using your iPhone for it to understand you? Basically or in your experience, has it already gotten that good? Because I know when Siri was first added, and this was a very long time ago, but when Siri was first added, they found that people with even just a Scottish accent, Siri just could not for the life of them understand them. You basically had to have a perfect Northern U.S. accent for it to understand you in the beginning.
Yeah. That's also another aspect. I've talked to friends and they have similar experiences to somebody who would have an Irish or Scottish accent. And people are like, man, these things suck. And I'm like, I don't know, it's been pretty good for me, I guess. But I guess I'm thankful for that in some ways, just because I do have a fairly standard American accent, which there's probably lots of data behind the scenes that it's learned from, aside from the user data like mine. And then as it does pick up recordings from me over time, it'll get better at mine and others. But as we collect more data, that will get better. It's something that we have to always be thinking about when we're developing models is, are we introducing bias? Because it's really about what's in the training data. So if the training data, if we don't have a lot of Scottish accent training data, it's not going to be able to learn that accent. And that's one of the biggest problems in machine learning is, getting high quality data. That's sort of what I was trying to tackle this summer, or aspects of that. And so
you're saying that even though it was bad in the past and it's not perfect now, that you think it will be rapidly, noticeably better. That's something that will improve rapidly in the next few years. That's one of those things we'll probably stop complaining about soon, you would guess, with the newest stuff. I know it's hard to say that because people will go, it's still not perfect, and it always varies.
I think it will get better. I'm not sure about the rate because I feel like it's been in our, applications for a little while now. So if you have a, more fringe accent, then it might take longer for it to be normal for you. It might, be acceptable for you. But so it really depends on how different the accent is from standard English. But over time, it will get better as we get more data, which takes time to get. Well,
and I think there's another question you have to ask, which is, I'm going to be honest. I mostly type now that I'm an online, put in quotations, personality. I don't really write much down. I'm writing down notes, as you can see here. I hold it up to the camera for myself, but it's only for myself. And it's funny. I was playing, Hitman 3 the other day, and there was basically a mission that was the movie Knives Out, effectively, and I had to solve a murder in a big mansion. And I wrote down notes, scribbles on a piece of paper while I was playing as a detective. And then I looked at it and I was like, this is entirely illegible. I can barely read it myself. So at what point do we expect AI to be able to read our handwriting better than we can? Because I would not expect anyone to be able to have read that piece of paper from that day.
Well, we have a lot of handwriting out there and a lot of different types of handwriting. I don't know that will ever get much better than it already is, honestly. Maybe if we start getting symbolic recognition working in neural processing. But as neural networks are today, with the hardware that we have now and basically the types of logic we have, if it's really far, if a scribble is very far from the standard, it's gonna find it difficult just because it hasn't seen that before, and it might actually look like something else. And how do you discern that? And so it'll get maybe slightly better, but until we have something that's a lot different, I think that it's only going to get marginally better, at least with that.
Well, yeah, and I mean, just as an example, like this is not to throw my mom under the bus here, but she has real bad handwriting. Like I definitely got it
Me
from
too.
her. Well, yeah, but her handwriting is also in this way, and I notice it from a lot of people from a previous generation where their handwriting is just, not to be brutal here, but from my perspective, not correct. like, like they won't close the top of an A. And I'm
Mhm.
like, well, then it's a U. If it's a lowercase a and you don't close it, it's a mom. I'm like, this literally you wrote a U. Like, this isn't up for debate. This is what a U looks like. That's what you wrote. And like, should we really blame AI for not knowing? I mean, you wrote a U, dude. I don't know what you want me to say.
Yeah, that's what it do on a character by character basis.
But
Over time,
yeah.
it can understand context of a word. Like if I
Mhm.
write computer and it sees a W for the M, and be like, oh, that's probably it.
Which is what our own brains do. Like,
Yeah,
there's been studies that are funny. You can write a paragraph and then you can just change some of the words. But because of context, your brain will literally see a different word if you read it quickly.
yeah. In fact, you can scramble letters and we can still understand it. I'm sure we've all seen that and had fun like
Mhm.
reading things that totally are not even close to English, but we still understand it perfectly well, and
Mhm.
we can read pretty fast actually. If you feed that into a neural network, it might get tricked really easily, really fast because they don't generalize that well.
Mhm. So that's something they could still work on, but for the most part, you don't think it needs better hardware, just a bit more data, and that aspect of identifying handwriting is close to as good as it's gonna get already.
As is right now, until we have a lot better natural language processing. But I mean, I'm not super familiar with the applications that use it as of now, and what
Mhm.
they look like. I don't have experience working with them or even using them, but I can imagine how it would work, and that's sort of what I'm talking about.
And you do a lot of stuff with audio. So Sarcastro writes in, I think this should put a cap on this part of the conversation. He goes, good day, Tom and guest. Regarding voice training with AI and machine learning, how close are we from something along the lines of something in Star Trek like a universal translator with the capability of smartphones, smartwatches, and devices that can carry phone signals to the ear through the ring finger? When I first heard of devices being developed to use our biomass as a conductor to carry a signal in this manner, I began wondering how much longer until a device can translate in near real time my desire for room temperature soda to a Japanese family I'm visiting and in return convey their shock at my preference. Like, so I guess he's really asking a few things there, actually. That last
Yeah.
sentence just took it up another whole magnitude of
Oh yeah.
how hard it would be. But how soon to where we can have an earpiece? And I know they're trying to do it at least with visual stuff, like, and you can hear things and it just reads it into your ear what they're saying accurately. Like, are we close to that right now, or?
That takes a lot of neuroscience. I don't think that we're there yet in terms of understanding the neuroscience behind that. I'm not up to date on the current research with all that, but
Mhm.
based on what I know of what there is today, that's quite a ways off before like even natural language processing. There's a lot of problems with language translation as is, so we don't even have an accurate like a fully accurate way to translate speech. And I think the first step would be just having an application that you can just a universal translator or there's like Google Translate. It still is not that great. Um,
Mhm.
and so the first step is just getting locking that down. And as we go along, there's also Neuralink that I think Elon Musk is working on. I think that's what it's called. And
Yeah, it is.
there's a lot of different bio integration going on, and that's a whole nother aspect of the research. And that's also very far away before we can start sending messages like that, complex signals to our brains that way.
So you think, in other words, right? Step one is just making the apps we have now work.
Yeah,
Step two is making it work in an earpiece. And step three is, and you're not going to even speculate on when we can put it in a brain, basically.
yeah, that's working in an earpiece. That as soon as we have it, so if it's going straight from our finger to an earpiece, I think that's just simple passing a message along. That's fairly simple to do. It's just a microphone in your ear. Um,
Hmm.
but yeah, to get that to work, like the translator, we have to get the translation logic down, and we have to be able to do that really well.
The only thing I would add to his question is just to touch on it. Like he said, so like when will we go from it direct translating to like doing it without me telling it to do it? And then also knowing I was going to tell someone and then telling them and then them reacting to it. Like, is that kind of where you see this whole body thing and AI going? Like, are you concerned about AI becoming as smart as a person and then Skynet killing us? Or are you expecting it to be more so we're just going to make things we already do quicker by having a computer inside of us do things quicker than we is AI research's natural conclusion going to be enhancing our own brain or making another brain? Right. I know I just asked a huge big picture question.
Just to reiterate, is AI going in the direction of just enhancing our experience and enhancing what we can do with our brains and sort of integrating with that, or is it going in the direction of just creating an entire new intelligent being per se?
Right. I it's hard for me to ask exactly the question. This whole concept, all these concepts, it's hard to put them into one question, right?
Mhm.
That makes sense. But I'm kind of asking that because I think a lot of people, are worried about Skynet. And like, for example, Go-Kart writes in and he says, "Dear guest, are you worried you'll be the one who creates Skynet? Have you ever considered strapping C4 to your work PC just in case it tries to kill you? And finally, can you please ask our AI overlords to put me on a hamster wheel rather than a tub of goo? Thank you. I'm just a concerned nerd." So like, do you see AI evolving into something we have to worry about yet? Or do you think it's just going to keep becoming things that make things quicker that our brains don't have to do anymore?
I think it's the latter. As at least as of now, I haven't had to worry about any C4 in my laptop. I haven't had to worry about anything related to that yet. Because again, they're very narrow scopes. I was specifically working on training new language or new vocabulary terms into a speech to text model, something that would listen to somebody and then turn that into text. That's not going to take over the world. And I think that goes back to one of the biggest misconceptions that I personally see, and in terms of what people see AI as it is today, is that it's not going to generalize. These neural networks, they don't generalize to new functions, new tasks. They work in a very narrow scope of inputs and a very narrow scope of outputs. Now, in terms of in the long term future, do I see something like Skynet, being possible? If I was to try to implement a really intelligent AI right now, I would try to aggregate a bunch of different tasks in AI research right now, but it would still be very incapable at a lot of things. And so, in terms of Skynet, I've said this before. I think that we're going to need something very drastically different in terms of how we model intelligence. And something that is completely brand new, something that simulates some sort of creativity or creativity. I don't know, some sort of symbolic representation of things around it. Understanding its own position in the world, understanding the experiences and knowledge of other things, and how that all relates. And we're very far from that because everything that we have right now is again very narrow in scope.
Well, and then let me ask it to you this way, right? I just was Googling something there and while you're talking, and just to refresh myself on specifically what articles I've seen, like, when I was in college, I saw them like, oh, we'll have general AI as soon as 2030. And I see some people now all of a sudden saying 2050. I remember when I was in college, I was like, I don't know, maybe 2040. But the more I look at things, the more I look at how Tesla's got a problem with their, AI just apparently driving Teslas into cop cars lately.
What?
Like, yeah, apparently, I don't know if they fixed it. It happened like a half a dozen times or something. Don't quote me on the exact number, but it wasn't like once or twice. It was like a few times. A cop car on the side of the road who had pulled someone over just has the flashing lights, and the Tesla car just out of nowhere steers right into it, which is an insane mistake. And I test drove a Tesla. They came to Peoria when I lived there a couple of years ago in Peoria, Illinois. And they're like, "Hey, we got Teslas here. You want to try one?" And I'm like, "Let me try autopilot." And they assured me when I got back, "Oh, this is the last gen autopilot." It stopped at a green light and didn't go on and didn't stop at a red light once. And I was like, never buying this for the next 5 years.
Oh gosh.
Like, so like when I see these estimations of when we'll have general AI, I'm like, I don't know. Right now, they seem to just be driving into other cars half the time. And again, I know it's not half the time. I know it's very rare. I know some people would argue it's safer than a real person. But what I can say is I've never almost done that. And the fact that this can almost do that, this can do that 1 in a million times is a concern of mine, because that's not a fender bender. That's a huge accident.
Yeah.
So like, do you think general AI is going to happen in 2030, 2050? It kind of sounds like what you're saying is we're not even at the beginning of making that.
There's a couple different things I want to say. At first, where we are now, we're on the cusp of integrating, neural networks, all over the place. And as we further integrate machine learning into applications and throughout our lives, there's very real consequences, especially with Teslas and self-driving cars. We have to be very careful in terms of where we use it, because it can be wrong. They're going to produce an output no matter what, because you're asking it to. That's what the program does. And that output might not be correct. And that's just sort of the nature of machine learning. And then as for where, in terms of a general AI, we're going to need something different. I've tried to do a little bit of research on what people are doing right now in terms of general AI. And there's this idea of the neuromorphic computing and the spiking neural networks, where like it's a different model of the neuron. And so people are trying to model the brain on a much more closer level to what it does, much more accurate to what the neurons do. And I think that might be a step in the right direction. It has yet to pan out yet, but there's a lot more that we have to do. And I think that if I had to put a number on it, I wouldn't say 2050 for a general AI. I would say something entirely new is going to have to come, spring forth in terms of how we do computation. And then that's going to have to be developed and researched and fully integrated before we can have a general AI, which could be closer to 2100, honestly.
How much of it, in your opinion, is processing power? Do we need, quantum computers, which I already know half of the people that I talk to in the field think those aren't ever going to be a real thing for anything but very specific tasks. Is it processing power, or is it just, it's hard to say, like we're just so far away from even knowing how to solve the problem?
We are extremely far from being able to know how to solve the problem. In terms of quantum computing, there's a lot of tasks that it can do with the way it computes probabilistically. It's much more efficient at some types of calculations, and it's scary the impact that quantum computing can have as it gets further developed. I don't know that much about quantum computing. I'm not an expert in that field, and I think it's going to have significant impacts, as a lot of new technology does. But the same thing with neural networks now and machine learning. And every time something new comes out, people, start imagining all these potential possibilities, which is great. And we start using it as much as we can and using it all over the place, and it improves the human condition in a lot of ways. But it's still not like the silver bullet for solving general AI or these really gigantic problems that we have. These really high level tasks that we want to get done, like general AI.
So you don't think, that's interesting. You're basically saying there's no silver bullet for AI. Like, it's not just processing power. It's not just data. We're just so far away. It's hard to say what's needed, right?
I'm not saying it's not possible, but I am saying that we're very far from it. And I don't think that any specific piece of technology that we have right now, if we just had it a little bit better or a lot better, we would have the general AI. I think that we need something very different.
Well, yeah, and I'm someone who never says never. Absolutely. Yeah. Well, I mean, come on. Look at what we have now. It's like, let's not pretend something's impossible necessarily, but I just, like I kind of was saying before I got myself sidetracked as usual, I don't see the cusp. 2020, 2030, no. In 2050, I don't know. That's decades from now. I doubt it. I really am just doubting a lot of the Jetson futurism ideas now of like, yeah, I think we're going to have crazy advanced things in 20 years, but I'm starting to doubt half of those futurism concepts is coming around anytime soon, because it just seems like they're still very far away.
Yeah, and a lot of the way that we're integrating a lot of these concepts now, like a self-driving car, there's dozens of programs and applications being accumulated to just do that one task. And if any of them fails, you're going to hit a cop car. And it's just very far from what we need in terms of actual intelligence. And I think we're kind of limited by how we understand ourselves in our own brains. And that's sort of what's so interesting to me about studying AI and learning about it is I'm learning about myself and my own intelligence, and how I think and process things. And we don't fully understand how our brains work. We don't fully understand how to model creativity and intelligence. And I think that's a very huge limiting factor right now.
I mean, yeah, without going down an entirely different rabbit hole of a discussion, the more I start thinking about modeling AI, the more I start thinking, oh, we don't even know anything about ourselves. Like everyone not everyone, some people are very self-aware, but a lot of people like really have no concept of what they actually look and act like. And like, so how are we supposed to model an AI if the average person actually has no clue of what they themselves are really like?
Hopefully, eventually we can have an AI that might be better at that, which I guess has a lot of implications.
Which would be the use, right?
Yeah.
That's why we would make it.
We want to take the human brain evolved over millions of years, and through tooth and claw and fighting and competition, we have what we have today, and it's really powerful. But hopefully we can take the best aspects of our intelligence and then use a lot more access to data and a lot higher computing power to create some sort of artificial intelligence that can do really cool stuff, really useful stuff, and maybe automate a lot of processes that can free us up to go do other great things. And so that's sort of the goal, right? And so we have a lot to learn about ourselves before we can have the things that we're discussing.
So something that I want to go back then, because we definitely are jumping all around the script, which is typical. But I want to take it all the way back then to one of the early questions and just ask this one. Michael Miggy writes, and he says, as someone who isn't involved in AI or machine learning in my day-to-day, I hear these terms tossed around like all hot buzzwords tend to be. Could you lay out the differences between what an algorithm and what AI are? How machine learning is different from every other kind of learning, and where these technologies make sense to use, and even more importantly, where they don't. And I think it's like, because I would just want to highlight, even algorithm is a term used too much. I hear algorithm and I look around and I'm like, you mean a whitelist? You don't have an algorithm. You just have a whitelist for like what's allowed to be used. And like Google's algorithm is mostly just a whitelist for keywords, for like, so.
So algorithms they're a very specific set of replicable steps that solve a very specific problem. An algorithm is just a set of instructions, and we can turn that into code or some sort of logic, and the logic is used in algorithms. And then when you're talking about machine learning, there a lot of the models, they're called machine learning algorithms, like ADA boost or random forest, decision trees, logistic regression. These types of these models, they're just algorithms. And the same thing sort of goes for a neural network. There's a specific set of instructions that makes a neural network work. It's just a little bit more complex than a machine learning algorithm. I mean, it is a machine learning algorithm. It's just a little bit more complex, and it's based around this idea of a perceptron or a neuron. And so when we're trying to understand the differences between AI and just logic or an algorithm, what the term AI is supposed to represent is this general goal of ours to simulate or replicate an aspect of human intelligence. It's not necessarily to get away from logic or algorithms and structure, but we're using these things, algorithms and logic and all that, to simulate something that our brains are doing, whether we're doing it to the best way possible or not. The difference between machine learning and neural networks is really just about the structure of the algorithm, but it's still all just a set of instructions.
Right. So, what do I want to say? So AI is new decision-making or modeling of stuff people do, and an algorithm is just making the best, basically basically equation for estimating the correct answer, right? Or whatever that answer may be, up-resing a video game, does a YouTube video have questionable content in it? That type of stuff, right? That's really, an algorithm, it's pre-put together, and I think, this has AI. It's like it's doing something new every time. Is that a way to think about it, or?
Yeah, I mean, when I first started, I had this thing. I was like, oh my gosh, I don't like the word AI because it's just a set of instructions. And then as I start working with it, I can start as I understand it more, I start seeing it more as instructions and algorithms. But then I sort of get over this hump where I start realizing that it's about what we're modeling. It's the goal. It's not about the instructions and the algorithms. It's actually about the piece of intelligence that we're trying to model, whether it's learning from past experience or data, or if we're trying to simulate a character that does something in a video game. Or maybe we're creating a robot that cleans the floor, and we're trying to figure out the best way to intelligently plan that path. There are logic and instructions behind that. There's algorithms that do it, but it's just a subset of what we're trying to do, which is model intelligence.
Mm-hmm.
And so, AI is this really broad term, and then machine learning is a narrow subset within AI.
Of that, yeah.
And then deep neural networks are a subset within machine learning. And those two learning tasks are just trying to learn from data to do some sort of inference.
In other words, though, yeah. So AI is the umbrella term for all these other things. So in other words, what you're basically saying is almost every time any app says it uses AI, it's not. The AI was already done beforehand for it, or, something like that, because that the AI is the work you do in the background, kind of, to create the algorithm or to create a program, that it's not, that it really doesn't mean anything if you're like, this is an AI thing or something.
That's an interesting way to look at it. That's a really interesting way to look at it. It's not AI once it's implemented. But as we're working on it, we're trying to model something. So we're doing AI research. But then once it's implemented, it's just, the instructions. That's it. That sort of algorithm is what's in the application.
Unless you're talking about literally the AI in a video game. And even then, it's really just a different term at this point. Right?
Even that is still just a collection of things that are happening behind the scenes from different inputs and outputs and different logic, and it has its own internal representation of the world around it, but it's still all happening in code.
Taiwan number 1 says, hello, Tom and guest. Do you think maybe we should stop calling it AI and instead rename it to smart automation or adaptive automation? When regular folks hear the word AI, they always think of things like Skynet or Ex Machina or the Matrix, self-conscious machines that are going to kill us. I feel like a lot of this fear towards AI is due to this misconception that we are trying to create sentient beings. But in fact, 99%, or honestly, it's probably more than that, my friend, of all AIs are just using algorithms to automate mundane everyday work and increase productivity.
This Taiwan number 1 is, he's hitting it right on the nail on the head. I actually kind of like the name adaptive automation. It sort of gets away from this human, mystification. If we call it like smart automation, then it's still this mystification that's happening that sort of scrubs away, what's actually happening behind the scenes. The term AI, it is sort of used as a buzzword that encapsulates a lot of different things. And so there are people who are working on, maybe a Skynet or Ex Machina, but it's the vast majority, and you're right, 99+% is just doing some sort of specific implementation in an application to enhance the experience for image processing, language processing, something. So I think that would I rename AI? Maybe not. I don't know. That's not necessarily my call, but I do think that using different terms is probably a good idea because it does get rid of some of that confusion.
Yeah, well, I mean, you see this other term thrown around. They don't use it as much anymore, but you'd agree with me. Like 3 years ago, all of a sudden, every commercial said "auto magically."
I do remember that. I don't remember.
They've seemed to stop. They've moved on to other bus terms. But yeah, it's like if it was automatic and it seemed like it shouldn't be automatic. I think what I'm saying is AI, I think they want the mysticism because they want you to think something crazier is going on than we took a year to make an extra smart or extra competent algorithm for finding you what you want. And yeah, that adaptive automation I actually like that a lot because it's like, well, it's automated, but it can adapt to a few parameters and we didn't used to be able to do that,
exactly.
Basically.
And I think that's more closer to machine learning. Maybe I've heard machine intelligence, sort of trying to, instead of artificial intelligence, it's machine intelligence.
Isn't that just the same word? You just said the same. You just said a synonym, machine instead of artificial. Come on.
Yeah. And this question sort of reminds me of when I was reading about the different neural engines. There's so many different terms actually. There's like IPU, VPU, NPU,
Yes.
CPU, neural engine.
And I was confused about that as well. I had to ask my Intel contacts, like, you say VPU, is this the same thing? And then I finally found a page on Intel's website that's like, this VPU also is automated for more neural engine tasks. And I'm like, all right, so it's the same thing. Okay, good.
It's just lots of matrix calculations. They have these matrix multiplication units, and then they have like these systolic arrays that sort of multiply lots of things all at once. I don't want to get too much into the technicals, but they're just highly optimized for a very specific type of instructions. And because we're using it in all of these applications and contexts, it's becoming really efficient to include these kinds of chips in our chips. If that makes sense.
Yeah, right. And the general point then is, again, like you said, it's good at, let's stop the mystification. It's good at doing these types of operations that are not what a CPU specifically does and not what a GPU does, or even if they can, it does it so it 10 times less energy usage. That yes, these parts of the chips are dormant for a lot of the time, but when you really need that spoon, it's way better than just having a bigger fork, for example, for that analogy. Now, this leads me to another question from Taiwan number 1. He says, do you think there is a market for all of these AI chip startups? Big companies like Google, Amazon, Facebook, and Microsoft will and probably are already designing their own accelerators. Smaller companies and academia are more likely to stick with NVIDIA GPUs due to their CUDA ecosystem or use FPGAs for more flexibility. Who is going to buy and rewrite their software for all of these unproven chips from startups?
I'd say a lot of people. Each of these chips have their own APIs and ways to communicate to them, and they are really useful at this specific set of tasks. I think it's one of the biggest reasons why Apple included it on their chip, is because it's really useful. I do see an increasing demand for it. It's really all about the demand for these types of calculations for neural networks, how far we're going to take them, how much we're going to use them. And I see it being further and further integrated everywhere. So there's a huge demand.
Right. And it's like, obviously, some of them might not be needed, but you're saying, no, there's a boom because this really is going to be used everywhere soon, or in a way it wasn't before.
I do want to sort of mention that it might not be necessarily used everywhere. Like it has its
everything
drawbacks.
will need it sometimes. And yeah, you're right. Because you have to be very specific, right?
It's very specific context that it's used in. And the nature of machine learning is it's always going to produce an answer. There's drawbacks in that to using these algorithms, and they will always produce an answer based on the data that they've learned from. And that can be biased, it can be incorrect, it can, it's not necessarily the silver bullet. It's going to be used everywhere, and it's going to revolutionize our world. But it's going to change a lot of things, and it's going to be used in a lot of contexts, and it has its own implications. But so there's a growing demand, but it's not necessarily going to be used as much as maybe CPUs are.
No.
So
you need a CPU in the device.
Yeah,
like
exactly.
You actually, literally the word need. You need it. You don't want it. You need it.
Yeah, exactly.
The way I think about it, too, the more we talk about this, is I feel like the immediate thing people will notice, but that they probably won't notice, is that in the next 5 years, I don't know that there's going to be anything magical that happens in the next 5 years once neural engines are in a lot of, let's say most mainstream SoCs. I think what you're going to see is the things we were already trying to do a decade ago work now.
Yeah.
Right? And that's going to be the biggest thing. And people will go, what did these ever do? And it's like, well, you notice how Google Translate works now? That's because of that.
I mean, gosh, yeah. Like face recognition on your phone would probably not necessarily be possible if they had to ping a cloud server. And so they had to start developing better chips on their systems to do these tasks very quickly. And so things are going to get faster on your phone. Things are going to get higher quality. Resolution will get better in some contexts. I think when I was listening to a past show of yours, y'all were talking about in a low bandwidth situation, or maybe a lot of people are on a network, the video will start resolution might start getting bad, and then you can actually sort of use neural networks to upscale the quality of a video that you're watching on your laptop.
Right. That's for my Meteor Lake neural engine leak. I literally just sat there and I'm like, okay, so it is really coming. I now have multiple sources saying this, not just like one. And I talked to a guy until for like an hour, like, no, but what will this be used for? And something that I stumbled into is, yeah, if bandwidth is low in an apartment building and your device might dynamically go, we have a lot of battery life left in your phone, but not a lot of bandwidth. So we're going to upscale. We're actually going to decide to have the video streamed in 1080p instead of 4K, but then upres it so it looks close, right? And it can dynamically just decide what to do, and that you can do that before,
Mm-hmm. Yeah, it's going to be used in all kinds of contexts like that to just enhance things.
Gosh, Reese, why does Windows 10 Professional have to be so expensive? Don't listen to that, nerd. Listen to me. You can get all the great Windows and gaming keys you need at cdkeyoffers.com. That includes Steam, Origin, Uplay, PlayStation, PC, and many other keys, including Windows, Microsoft Word, and Professional. Use the offer code BrokenSilicon for 25% off all of these fancy Windows keys and Dashing for 3% off everything on the website. One more time, go to cdkoffers.com. They're a fantastic sponsor of Moore's Law is Dead. Use offer code DASHRINK for 3% off everything on the website and Broken Silicon for 25% off all Windows products. Now, back to the show.
So Riza5 writes in, he asks, when training machine learning algorithms, to what extent are volumes of user-collected data required? If applicable, how do you go about collecting it? Is there a need to filter out dodgy data similar to some people clicking the wrong image on squares and captcha challenges on purpose?
So how do we go about collecting data? How much do we need to collect about people in applications? And that's another thing that really is dependent on the contexts. Like if you want to make it so that Siri only responds to your voice, you have to collect a little bit of data about the person's voice. Or if you wanted to get better at recognizing somebody's voice, you have to collect a little bit. And so that's sort of integrated into applications, when to collect data and how to collect it. And that's very application specific. And then as for cleaning bad data, that's actually like 80% of the job of somebody who's working with machine learning is just cleaning the data, getting rid of the bad stuff, making it higher quality, making sure it represents the problem that you're trying to model. If I want to train my neural network to learn new words, I have to give it those words. So I have to find the data, make the data, clean out words that I don't want necessarily. Or if data is mislabeled, I need to find those outliers. And so let's say for the CAPTCHA example, people intentionally clicking the wrong squares to for whatever reason. You know, that the way they might handle that, I don't know exactly how they do. The way I would probably handle that is I would have a lot of people try to, I would give a lot of people that image, and then I'd cross-reference and be like, okay, this person, or maybe I go majority vote on which squares are which. Or I would say, okay, this particular one is really different from the rest of them. There's mathematical ways to determine that kind of thing. And then I would get rid of that one.
And I think that's something my other AI guest said last year is like, no, seriously, though, like a significant portion of it is just making sure the data isn't bad, because you waste all the time if any of the data it will train it, but it's not going to be anything useful at the end. And it takes a long time and hours to run a training model or something, right?
I mean, for example, one of my professors that do research, it was some sort of a medical diagnosis type of research. And she was trying to determine like the best model to do this particular diagnosis. And it took them, I think it was like 3 years to get this medical data for this very specific context. And they tried a few different models, and they made, the different models made impacts on the performance improvements, but they spent a ton of time doing this data. And then the training took somewhere between like 3 and 6 months. That might have been because they were using poorer quality hardware. there might have been faster ways to do it, but it was dependent on what they had access to. And so 3 years of work to get this data for not a lot of training time in comparison.
Mm-hmm. So, kind of bringing it back full circle to one of our earlier conversations, Alex writes in and he says, "We all hear that algorithms and their thought processes are black boxes, and their true inner workings are a mystery, even to their creators. Are the inner thought," and he puts that in quotations, "processes of AI equally as mysterious? And if so, what safeguards can we put in place against the wrong conclusions outputs as we give them more and more autonomy over the aspects of our lives?" Like, so how much of that is a consideration though, like that these algorithms that you make through AI and machine learning just become black boxes and you don't, maybe they're really doing damaging things or something. Like for example, I remembered when I was putting this script together about some AI someone had to shut down because it created its own language and was talking to other AI, and they were like, "That's weird." And it was Facebook, and it's true. Like, I guess two of their devices had made its own language accidentally, according to this article, and just started talking to each other. And then they were like, "Well, we don't know what they're saying, so we're just deleting these AI."
So that sounds, when I read about that, that sounded more like a flaw in the algorithm to me, or like in their approach. Like again, machine learning is going to produce an output no matter what. You give it data, it's going to say something. It's going to classify or predict something. And, if you make a mistake and maybe don't put that constraint that they only, use this set of words, then they might start and you make it so that they can evolve the word slightly,
Mm-hmm.
and use different symbols or set of symbols, then it might slowly start changing. And if you have an error in the algorithm, then it might start rewarding things that don't make sense. And so we've inaccurately modeled intelligence, but it's not necessarily that it's created this abstract version of a new language that is now really dangerous. It's really not that intelligent, but it's just not useful for us because and so that's what a lot of machine learning is making sure that it's a really high quality prediction or a representation that we're giving it or letting it make.
Yeah, it's funny because you say that. And I was kind of thinking of it actually just now while I was asking you it's like, oh, what probably happened? They had a bad outcome, not bad as in dangerous, but as in a waste of their time. And so that's why they deleted it. But of course, a bunch of websites were like, oh, look, let's make this some flashy clickbait headline about how Facebook has dangerous AI they need to delete.
I mean, the word shut down, it's like, it sort of invokes a sense of urgency. But it probably wasn't. It was just like, okay, we need to approach this from a different angle, and that's probably exactly what happened. It's not like they were like, okay, how can we take over these people? Or it's not like they were saying that to each other. They were just. I mean, there is an aspect that they are black boxes that we can't see inside of. I mean, we can. It's just really not fun to go through each specific part of it, and the computations are very expensive and large. There's a lot of them going on. But it's again, it's more statistical fitting to data. It's how can we best draw a line in this data set, and then use that line to predict something. It's not necessarily going to generalize.
Okay, well, I have a few more questions here. We've been going for a while. I think we've actually gone through most of the questions, but so this is going to kind of be less of me trying to connect the conversations between each other and more so just throwing things at you. Carbon Cry writes in and he says, given the and I'm just going to spell it because I don't know how to say this, the LOIHI2 announcement recently, could you explain the difference between neural engines and neuromorphic chips?
So I'm not an expert on hardware and computer hardware, but I've done a little bit of research onto this. And as I was sort of doing my own research into general AI and the different approaches that we have right now, I learned about this thing called a spiking neural network. And it's still trying to model the brain from a neurological, like neuron perspective, like modeling neurons and how they connect to each other. But a spiking neural network is inherently different from a neural network. Like they're very different types of algorithms because the spiking neural network has a neuron and it's connected to many other ones, and so it receives inputs, analog inputs from a bunch of other ones, and then once it's accumulated enough charge, or reach an activation threshold, it'll send its signal on to the next neurons that it's connected to. And each of those, once they accumulate enough, they'll send their message along. And more specifically, the brain is sort of arranged in cortical columns of neurons. At least parts of the brain are arranged in these columns, and they sort of form computing blocks. All of these columns do. And each column might have a couple hundred neurons in it. And there's a lot of computation that happens on these, and there's a lot. That's a whole other conversation, and that's that's some of the neuroscience. And so the spike, and the reason I mention all that is because the spiking neural network tries to represent this idea of only firing once we've reached that activation threshold. And so the neuromorphic computer chips, from what I understand, are just an on-chip representation of neurons in that way. They still miss a lot of what happens in terms of how we encode information in these signals, but they're a next step of additional logic on top of what neural networks have today.
Okay.
And so I think it might be a step in the direction towards creating something that's could be revolutionary, or like the next big thing in AI. I don't know. It's still in its infancy stage.
Yeah.
And so,
well, like you've said, this is very specialized stuff.
Yeah.
No two AI research, I put in quotes, AI researchers are probably doing the same things. This is for a specific type of research.
Yeah, very specific. They're trying to model the brain on a much smaller level. That's sort of what the perceptron model, which is what we sort of have now with the neural networks that you see in every day today. They're trying to model the neuron, but it's like a stick figure compared to a human. And then, maybe now we have a stick figure with a little bit more detail.
And he's got a smiley face on him now.
Exactly. Or maybe my first grade self drew it. And so it just making it a little bit more intelligent. It might be the step in the next direction. Maybe we need to go in a totally different direction. I don't really know too much about it yet.
Yeah, once neural engines are standard everywhere, maybe Apple then is the first to add a tiny neuromorphic component to their neural engine, so you can do this other really specific task quickly or something. Yeah, okay, that makes sense. Taiwan number 1 writes in again, and he says, "Hello, Tom and guest. Jim Keller and Raja Kaduri described the AI chips as having a spatial, in quotes, structure rather than the traditional scalar vector matrix architecture. Could you explain to us what is a spatial structure? Why and how does AI workflow benefit from this design? Also, is this related to network on a chip? Thank you both for your time."
Again, I'm not super well versed on the computer hardware side of things, but I know a little bit. So these AI accelerators, they're just ASICs that are designed specifically for a set of computations. And so these chips, or these pods, have specifically what we need for these common set of operations. There's a lot of different types of neural networks, which I haven't even come close to talking about today.
Yeah.
But there's some very common calculations that happen, like the multiply, accumulate, applying activation functions. There's a bunch of other stuff, like convolution matrices and stuff. But so when they're at, I'm not sure what the spatial component is, but from my understanding of these chips, one thing that they have is this little grid of 8-bit precision integers that they then apply a vector, I think it's called a systolic array, to, which sort of it passes over the whole chip, or the whole square, and sort of multiplies and accumulates these values the way that the computation necessitates. And so it's a very specific thing, and it's not really great for other tasks. But they basically just have a few different components on these chips that do very specific tasks. And so when they're asked, so the difference between a GPU and one of these neural engines is one of the largest parts of the neural engine is that multiply accumulate grid, that piece. And so that's sort of in a 2D array, 2D structure, while in a GPU you might be doing it vector wise, so like in a list, so 1D versus 2D,
right?
And so it allows you to just do mass stamp up functions and processes to the numbers. That makes sense. And then a CPU might do a scalar value, so like just one singular value. Let's multiply two ones and then output one value to this register. So we'll go to this register, take that input, take this register, take that input, we'll multiply, add things, and output one value. GPUs sort of do it in batches, and they can do it in a highly parallel fashion. and then the neural processing units have these matrix operations that they're really good at.
Yeah,
Sure.
that's also a good way to just add on top of like explaining again why neural engines are being added. Is it's like, well, the CPU tells everything what to do, but it's like real specific. You do this, and the GPU does lists of things really quickly, and the neural engine can do matrices really quickly. Basically, I'm simplifying it, but. All right. Alex writes in and he says, I know that often very sci-fi like general AI is considered to be the holy grail of AI development, but is it possible that a neural engine can one day, puts in quotation marks, probably saying whoever knows what that one day is, be mastered within video games to provide dynamic enemy NPCs that respond in real time to players and bypass the need for an extensive developer programming? We all know where the NPCs are dumb as mud and they suck. And, I want to give an example, too, of like specifically, because I think what he's kind of asking is could maybe it would be good to have a general AI, not like a human one, but you know what I mean? Like a general game AI that you could put into multiple games. Because I know that in every game, it just takes a ton of effort to make it smart, even if you're like making a sequel. Like an example I would give that I remember, and I've seen this in a lot of sequels to games. Like I've seen some follow-up Call of Duties where the AI is dumber than the previous one for some reason. Or I remember Killzone 2's AI felt way smarter than, and Killzone 3's, because those were similar, were way smarter than Shadowfall's AI. That they put all this effort in the sequel into making the graphics, and you'd think they could just copy and paste the same soldiers into the next game. They just seemed dumber once they made it more of an open map, like just so much dumber. And then you realize how much of it was per level if-then statements to make them not stupid.
It's I don't personally see video game AI, like the fundamentals of it, changing all that much. Again, these are production environments that people are creating. Like they're competing for people's time, and they need to create the most immersive and awesome experience for people. And they don't necessarily want something that's an unknown. They want to know exactly what their characters are going to do in certain contexts, and then they're going to make sure that they do that. And applying machine learning might not be the way to go, because especially if you're trying to do it across different video games, there's just very different contexts that do need to be specific. So certain aspects of the AI you can generalize, and you can just copy and paste from game to game, and then sort of make things more specific. But I don't see a brand new structure for how these things think happening anytime soon.
Right, because the idea that you probably saw in my notes, my logical conclusion was, well, Sony has all these game studios, so does Microsoft and like EA. What if you just had Microsoft come up with one general Microsoft game AI that they could copy and paste into any new game being made, whether a racing, a shooter, or maybe even just for shooters. And then from there, you're like, hey, this is our general AI for playing games. Tell it it's playing a racing game and tweak it to be smarter or dumber. You don't think that's coming anytime soon? Because they basically have to make a new AI for every game. It's so hard.
They don't have to do it from scratch, though.
Right.
A lot of the specific tasks that an AI would have to do don't necessarily change from game to game. So they can, like in a racing game, maybe like if you're going from one racing game to another racing game, you can copy and paste that. But if you're doing a shooter game to a racing game, there's just very different tasks that need to get done. And so, and they don't necessarily want to have I don't even know how they would have a neural network do that, because neural networks are so specific. So I don't see game AI changing all that much in terms of how they approach it. They do have to sort of create it specifically for each game.
And it's going to have to be that thing where each studio really does just have everything they've learned, that it doesn't really, you're saying there's no real impetus, or it doesn't really make sense for there to try to be some unified, Sony AI that they then meld into each game. That every studio already has made a lot of progress on their own, and they're probably not going to ask for anything. It'd take too much effort to try to do something like that anytime soon.
Yeah, it really depends on the tasks that need to get done in the game. And so if you can repeat those from game to game, then do that. If not, then you have to create something new.
So, all right, I have two final questions here. Just to wrap things up. AC666 writes in and he says, hello, Tom and guest. As an engineering undergrad, where would be a good place to start learning about machine learning? I'm just as informed as the next guy when it comes to this stuff. As always, keep up the great work.
That's a good question. There's actually a great little article that I read about something very similar. So there's this website called Kaggle, which is hosted by Google, and they have, CPUs, GPUs, TPUs that you can access, and lots of data sets. They sort of do these competitions that you can go and they'll put out a data set and they'll be like, okay, who can create the best model? And then a day or two later or whenever they'll post a test set, and then whoever has the model that does the best on the test set will win that competition. And that's a really cool thing to do. It gets you a lot of hands-on experience with data and data analysis and machine learning. It helps. I mean, it's great, and it's great for research too. And you can even use those models, I think. And so that's one way to do it. And
you're
so
saying like they do these competitions regularly, and you can even see what the models were everyone made.
All the time.
Oh yeah, so you get to learn through doing. Then you get to say, well, how did they solve it? Because that's how, honestly, later in college, that's how I learned in mechanical engineering. Is it's just like, oh my God, let me just find someone else who solved a similar problem online, and then I can see why he did it and go, oh, so that's how we do this.
Exactly. So if you want to get into machine learning and applied machine learning, Kaggle is a really great place to start. I mean, obviously, I would learn Python first. If you don't know some rudimentary programming concepts, you could take courses at your college. I'm doing the same, and getting a lot of benefit from that. That's a great way to go. You could do a side project, just sort of, okay, let's take some Spotify data and see if I can learn something. Let's see if we can classify, maybe predict what decade this song was produced in based on the danceability and the volume and all these aspects of it. Let's see if we can classify it into a decade or something.
I bet consistent volume would be the number one indicator.
Yeah,
honestly,
there's a lot of so it really depends on the data that's collected from Spotify, because there's an API that you can just get the data from. I've looked into that a little bit. So it's to sum up, the answer to the question. You take some courses. Definitely try to create a Kaggle presence. That's something I'm trying to work on now, just because there's just so much going on there, and then and a lot of great information there too. And then personal projects are a great way to go, especially if you're learning something like Python and some of the data frameworks that they have for that language. So yeah, that's how I would get started.
All right, and that perfectly leads into the final question then. Valko Molev asks, hi, I want to get a new job as an AI dev researcher and immigrate somewhere to the West like Germany or Austria. I'm currently in Bulgaria, so I am in the EU. Because currently, I'm working in at a big data processing company, and I'm in the data automation team. I've done some internal projects. He says, I have a good understanding of TensorFlow, and I also have several personal projects and one professional on this framework. I also plan to participate in some Kaggle challenges, or Kaggle, I think you said. I have some programs for past challenges, but I didn't think that they are enough to release them. And I also have some understanding of math. I have an engineering degree in computers. In addition to this, I'm reading specialized literature in graph theory and neural network on a daily basis. I'm also doing some networking in the AI social networks. My question is, what can I do in addition to this to solidify my transition to such a job? Do you have any advice on writing papers besides should just do it and change some hyperparameters of an existing architecture, get a 0.5% improvement and write a paper about it? I'm currently exploring the autoencoders and have one amateur paper on them. I want to ask you what math fields topics are important to AI, including the ones that can contribute to new and interesting research. And the final is a joke question, but I want to ask it. What would happen to common people if artificial general intelligence is invented and widespread? Will the governments and the ruling elite just dispose of us, or will we all live together? So I guess let's leave that last one out here and just answer the first set of questions. You gave us a lot of information.
I mean, they seem to be going along a pretty good approach. I'm not necessarily the person asked to about like what's the best way to fully become established, because I'm still establishing myself. But other than Kaggle and doing side projects and working at the maybe a big data firm, gosh, I mean there's great things. Maybe there's a lot of machine learning engineering jobs. One of my goals is to eventually someday get one of those. It's a very huge and growing field, machine learning engineering, like applied machine learning. And so they also mentioned just maybe tweaking some parameters and getting slightly better results. Honestly, that's something that I've thought about a lot. Like, okay, what if I just do something similar to that? To sort of copy what's already out there and then just tweak it just a little bit.
Prove that you can add to something someone else did, which is most work.
Yeah, it's sort of prove that you sort of get the picture here. And I'd say personally, that might not be a bad approach. Because then you sort of establish a presence, sort of get your name out there so that you can do something. So I'm not totally sure about that, but it doesn't sound like a terrible idea. And then what kind of mathematics goes into it? From my understanding, a lot of the work in actually applying machine learning algorithms in the real world, you don't necessarily need to know the mathematics. Only really as far as you only really need to know it as far as understanding the difference between the models, so that you know when to use them, because certain problems require different algorithms, and some algorithms are better in some contexts than others. In fact, what I've heard is that a lot of machine learning engineers, most of what they do is also just very basic models. Is a lot of, there's not necessarily really complex tasks that need to get done, or complex predictive models that they need to create.
Or that can get done. Like they want do work that will actually have an end goal here that doesn't take 10 years to train,
Exactly.
Little iterative things is most work, really.
Exactly. And, if you have maybe a smaller company that you're working for, and you have a very specific domain that they need to, or maybe they have a small data set or even a large one, just, you don't have to reinvent the wheel. You can use what's out there already. And so just proving that you know how to use that stuff and when to use it, is really the name of the game, from my understanding. And so, yeah.
And what I would add on top of that, just the more general thing, because I've switched tons of jobs. I think I'm a little older than you, but not tons. Little. Is the good news is the bad news about how jobs seem to work now is it's becoming remote, so it's not like they're just going to fly you to Germany if you get a job. But that's also the good news, meaning they'll hire a remote worker. So I would just say make sure you're always learning. Seems like he is, because I've had that too, where I realized I wanted to switch jobs and I'm like, I'm getting bored. I'm not getting any better at doing anything. I'm just doing the same tasks every day. As long as you're still learning and working towards something, just keep applying to jobs that are in Germany, man. And eventually you'll probably get one remote and you work there for a few years and then they'll agree to move you out there if you do a good job. I mean, that's really what it takes, right? For almost any type of job where you want to move to somewhere new is I find that getting at the company, not expecting them to just move you there right away is probably the best strategy, because they don't want to move you right away until you've proven yourself for a few years. If that's the specifics of his end goal,
That's good advice.
All right. I wasn't sure. I couldn't tell if you were waiting to say something or not there, but
No.
I think we're both getting a bit tired then. We've talked for a while here, and I really appreciate you coming on to explain this. I think we stumbled into some interesting points about like Intel with Apple, and I would say to my audience, I'm learning just like a lot of you guys are what a lot of these words mean, and I'm only now starting to take it, very seriously. The final thing I'll say is there anything you want to plug? Like, I don't know. Like, I mean, I'll put some information about you in the description if you want me to. Otherwise, anything you want to plug related to you or related to anything.
I guess. Follow my LinkedIn. I guess it's the normal link, and then /RDHURLBU. And then I have an Instagram. I don't really use it all that much. I do use it sometimes. I take photos of places that I go and stuff. It's called the Herlass. It's spelled exactly like that, but the Herlass part is HURLASS. And I don't have a Twitter or anything. I do, but I don't really use it. Except to I go on.
I didn't until I had this channel. So
yeah, that makes sense.
Well, I guess I'll add your Instagram too. Then if you send me the link to it, I wrote down what you said though. Maybe you'll get a bunch of Instagram followers. But again, thanks for coming on to explain some of this stuff for everybody. And thank you to everybody for listening.
I had a lot of fun. Thank you so much.
This podcast was brought to you by the YouTube channel and website Moore's Law is Dead. Moore's Law is Dead and Broken Silicon are trademarks of their creator, Tom. That guy is me, and I am indeed the creator, editor, writer, and showrunner of Moore's Law is Dead podcasts, videos, articles, and other media. However, I don't do this alone. Moore's Law is Dead is a team, with Broken Silicon co-hosted by my brother, Dan, audio editing by Gerard Cortez, and special assistance by Carbon Cry. Find all of our information, including the information of sponsors you can support, at www.mooreslawsdead.com. If you would like to send fan mail or hardware to us, please mail parcels to Moore's Law is Dead at P.O. Box 60632 in Nashville, Tennessee, zip code 37206. And speaking of fans, patrons are what makes Moore's Law is Dead content possible. The aging business model of spamming ads all over the content is dying. The future of media will be built on fans paying for the content they actually want to exist. And so if you have the extra money, but only if you do, please consider supporting us. For just $2 a month, you get access to the exclusive podcast Die Shrink, voting on subjects of future podcast episodes, the ability to have your questions read aloud on Broken Silicon, Die Shrink, and Loose Ends, and of course, access to the Moore's Law is Dead Discord full of like-minded people who would love to meet you and talk to you about computer hardware. I am one of them. Additionally, higher tiers get access to ad-free episodes of Broken Silicon, the entire back catalog of Flyover States podcasts and other projects Moore's Law is Dead has done, and thanks in the credits of videos and other perks as well. And hey, if you can't afford to support us, please do share Moore's Law is Dead videos and podcasts with friends and family on social media, Reddit, and forums. And give Broken Silicon a 5-star review on Apple Podcast or your preferred podcast app. All of this really does help so much. And if you'd like to advertise on the podcast, hire Tom for consulting, or are a person of interest who would like to be a guest, please reach out to the email address mlhbdead@gmail.com. But as I said, this podcast would not be possible without its patrons supporting it. And so now it is time to give a personal thanks to the greatest of the fans. The following supporters are at the 10 gigahertz or higher producer levels: Brad Medlin, Telos, GUK, Benny Berlin, Justin Yacht, Thomas Rupp, I Love You, Lynn and Jim, Ivan K, Tom Bailey, Muhammad Al-Kawari, Frederick Lau, Metrocore, Justin Parrish, Zachary Martin, Terrence Harrod, Drita Full, Phil S, D31337 Antics, The Ninth Dude, Jesse Jaskowiak, Josh Law, JBG, Travis Goody, Mechanical Philosopher, Lebo King Kilo, Fatboy Deesru, Daniel Hyde, A Guy in PA 81, Nathan Mose, Cole Addict, Matt Salem, Aaron Close, Juan Garcia, Matthew Len Devazzo, My Name is Nobody, Judson N. Elethros, Jensen Wang, Hey There's a Kitty, Greg T. Wonchik, Ivan 214, John Jameson, Benjamin Cannon, Matthew Lane, Mark Raidmaker, Jan Rauner, Rickers Licata, Michael McGee, Ali Robertson, Eric Jackson, Jonathan, Patrick Groh, Evan Dingle, Dominique Cox, Stefan, Original Ross, Anthony Garefa, Joaquin Hagan, Total Silo, Sol Connor, Michael Acosta, Andrew S., Blake, Aaron Keith, Gregory S. Acker, Endless Loggins, Tom Sanfilippo, Justice Brennan, Zoot Suit Taylor, Trevor Power, Stu, Elenia, Nanya, Daniel Nishpal, Franco Frederic, Dan Galanowski, Ivan Clifford, Dark Rain 2049, Leighton Perry, Joseph Karen, Brett Summers, Judd Y., Donovan Russell, Noah Nicola, Zlicky, Martin Porshaggi, David Cowden, Ricky Tan, Hulam, Patrick J.S., Justin Staples, Freddie Canoas Jr., Stephen Coates, Kiwi Phil, Duhoo, Sarah Light, Mitchell Pell, Brett Summers, Eddie Del Castillo, Joseph Floria, Luis Correa, Deke, Cheesy Ramen, Tyler Lindley, Tim Robbins, Jake Dude 23, Brian Riggleman, Justin Gower, Caillou Markelli, Dave McCoy, Volko Malev, Gabe Langner, Ronnie Kaluyak Souza, Michael Deaton, MJB1, Maurice Courtois, Wesley Sager, Sarcastro, My Sharona, Y Truey, Roman, William W. Draper, Air Rats, Wakir Khan, Henry Zhang, Stephen Hart, Christopher A. Butler, Greg, Peter Moore, Amiable Chief, Justin Thomas, Sam Miller, Semi Malas, Kevin Chen, Shakir, Nick Rakin, Holden Mobley, Matthew Lazier, R. Pete Sharma, Meat and Pork, Jimmy N.G., Mads, Gordon Freeman, Benjamin Osley, Z. Jits, Shield TV Couteau, Aaron John Wissing, Sam Venzel, Mark Mitchell, Brucha, Jeremy Show, and James Anderson. And thank you to Sahara for the music.